All right, our last lesson in the probability chapter is all about the counting principle. And you've kind of already seen this through the different things that we've done with counting outcomes, listing tree diagrams and sample spaces. So this is probably the easiest method to getting your total possible outcomes. So your task is a pizza company makes pizza in 3 different sizes, small, medium, and large. And there are 4 possible toppings: pepperoni, sausage, green pepper, mushroom. How many different outcomes of or kinds of pizza with one topping are available? So, you could obviously draw this out in a tree diagram. You could make your sample space and get it, but there is a much easier way. So if we are looking at this, if the company makes 3 different sizes, we're going to list that first. So we're going to make that in a fraction format. We're going to say there are 3 sizes to the pizza, and the fractions are going to look a little different. They're going to have a number with a label to keep track of what you're counting. Then we're going to list the next thing, and I forgot to highlight this large, so small, medium, large, 3 sizes. There are 4 possible toppings: pepperoni, sausage, green pepper, and mushrooms. So we're going to list 4, and we're going to label that toppings. And so that is all the information we're giving. So all we're going to do is we're going to multiply our 3 different size pizzas times our 4 possible toppings, and that's going to tell us that we can get 12 outcomes or 12 different combinations of our pizzas. So pretty simple. All right. Using the counting principle to find the number of outcomes, you can choose from 3 types of sandwiches for lunch, 4 types of chips, and 3 types of juice. How many possible lunch combinations of sandwich, chips, and juice can you have? So we're going to list those out again. We're going to say there's 3 sandwiches times 4 different types of chips times 3 different types of juice. And you're going to multiply those across, and you are going to get 36 different combinations or outcomes. And that is it. Moving on to the second example or third example. You flip a coin twice, you roll a die, and you spin a spinner with 4 equal sections. So this one gets a little more complicated because of flipping this coin twice. You actually have to list it 2 times in your combination outcomes. So we know that coins have 2 sides to them. So I'm going to list the first flip as my label, and I'm going to say there are 2 sides to that coin. I'm going to multiply that by the coin being flipped a second time. Still 2 sides on that coin. And now I can move on to my die. So I know I'm only rolling the die once, so I'm going to list the die. And I know there are 6 sides, so there are 6 possible outcomes on that roll. And then for my spin, I'm only going to spin that once, and it tells me there are 4 equal sections. So when I multiply across, I get 96 different combinations. Moving on to example number 4. This one is a little tricky because there are a lot of specifics, so pay close attention. A 4-digit passcode using the numbers 0 through 9. The first and third digits are even, and the second and fourth digits are odd. How many combinations of passcodes can you have? So this probably seems overwhelming if you were to read this without me helping you out. So when you have something like a license plate, a passcode, things that have many different options, you want to actually give yourself a space to work in. So we know that it's a 4-digit passcode. So I'm going to draw 4 little lines representing my 4 digits in my passcode. I'm also given some very specific directions. I can only use 0 through 9, so I know I have 10 digits to choose from, but also the first and third digit have to be even. So I'm going to write that underneath them. And then the second and fourth digits have to be odd. So when I'm thinking about the numbers 0 through 10, and I write them down, 0, 2, 4, 6, 8, and 10 are all even numbers. So that is 1, 2, 3, 4, 5, 6 different outcomes for my evens. And then when I go through 1, 3, 5, 7, and 9, that's only 5 different odd outcomes. So when I multiply these all across, That's going to give me a very large number of outcomes because 5 times 6 is already 30, times 6 is 180, times 5 is 900 different combinations. And that is why we use so many different numbers on that, to make so many different combinations possible. All right, and the last one, we have a buffet line where you can choose from 4 different main courses. So I'm going to list 4 main. I like to kind of do this when I'm reading it. 5 different sides, 3 different drinks. Sorry, desserts first. And 3 different drinks. And that is it. So when you have a main course, a side, a dessert, and a drink, you have 180 different possible combinations. If you have more questions on this, there's kind of some reflective questions at the bottom. But other than that, that's it for this lesson. You can go ahead and do your